quadratic models, what we're going to be doing is looking at the parabola that we've just been looking at in real world situations. So the parabola is actually out there in the real world. You'll see it in headlights, in torches, solar furnaces, all the satellite dishes you see, and a few other things. So we're going to be looking at hopefully just the first quadrant because we're going to be looking at real world applications. So we're going to be looking at probably parts of parabolas. So let's have a look at our first example. In the first example, a girl throws a ball in the air, which is a classic example of a parabola. It goes up, it turns around, and it comes down. And we're given the equation h equals negative 5t squared plus 25t plus 1. And I've already graphed it here on the side. The first question says find the maximum height of the ball. So the maximum height, we'll just go up here and see where is that maximum height. It looks to be here. So I'm going to go and read that off on the y-axis. So that looks like it's got to be 32, looking at the scale, meters. When is the ball at its maximum height? So when is the time part or the x part? In this case, it's t. So I'm going to come down and that looks like it's at 2.5 seconds. So 2.5 seconds. At which two times is the ball 31 meters above the ground? Well, let's have a look where it's looking to be about 31. It's here and it is here. So that is at 2 and at 3 seconds. So it's at 2 because that's where it hits on the way up, and then it's at 3 seconds because that's where the ball is on the way down. So 2 and 2 seconds and 3 seconds. At what time is the height 0? So there's only actually one time when the height is 0, and that is here at the end. Because here it doesn't actually start at 0. So the time when the height is 0 is at 5 seconds. And what is the h value when t equals 6? So if we go to where t equals 6, you can see that I don't actually have, well, I could go down here and read it off. It looks like we have a value of, what's that, negative 29 meters, thereabouts. Negative 28, negative 29, negative 29 meters. And it says, what are the limitations on this model? Well, I think that that is a limitation because how on earth could my height be negative unless it's fallen into a hole? And yes, I've heard that one before. So in this context, we can only really look at the values between 0 and 5 for time. We can't look at any values higher than that because they don't make sense. Looking at this second question, we've got yet another parabola. It has a negative sign in front of it, so I know it is concave down. And I've been asked to complete the table of values. So I think we should pause it because you really need to practice putting in these numbers into your calculator and then come back and check your answer. So you can see the points that you should get are 5, 8, 9, 8, 5 and 0. And then you need to plot the points on this number plane and hopefully you should get a parabola. Have a go at doing that. So your parabola should look like a much better version than mine. Can you see in this case, I'm not putting arrows on the end of my curve because I'm not interested in any other values. I'm only interested in what is going on up here in the first quadrant. So now we just need to answer a couple of questions. The first question being, from the graph, find the maximum height of the object. So once again, we're going to look up here for the maximum height. This looks to be the maximum point, and that is a value of 9. So the maximum height is 9 meters. When does the maximum height occur? Well, I'm looking at the x value, and that is in 2 seconds. What was the initial height of the object? Well, the initial height is when time is 0. So here gives me the initial height. So the initial height was 5 meters. And when does the object hit the ground? Well, here must be when the object has hit the ground, and that is after 5 seconds. So the next question says, the value of a gemstone is directly related, and we've seen this before when we've seen our directly proportional or directly related to the square of its weight, and can be modeled using the quadratic equation in the form of V equals AW squared. So I know it's a parabola because it's got that squared. So it says now in part A, if we have a 4-carat stone and it's valued at $200, write the equation to model the relationship between the value of the weight and the gemstone. So we've got V equals AW squared. And we're told that a 4-carat stone is valued at $200. So the value of $200 for a 4-carat stone. So I'm substituting those numbers in so that I can find out what that constant A is worth. So when I do that, I get A equals 12.5. So write the equation. My equation now is V equals 12.5 W squared. So once I have that, now I'm being asked to fill in a table of values and to graph it. Now the first thing is, before I even fill in the table of values, I look at this and I should have a curve that is concave up. So I should have part of a smiley face. So keep that in mind as you're substituting the numbers in. Have a go, substitute the numbers, draw the graph, and then come back after you've done that. So here are the answers to the table if you filled it in correctly. And this is what my graph looks like. It's not a fabulous looking graph, but you guys can do a lot better than me. Now, I know that it's a parabola because it's got the x squared, so I don't want to be trying to draw a straight line. My line does, I do have a curve. And if you can imagine my parabola, if I could actually do it, it would continue around the other side. But I'm not interested in that part at this point in time. So now we're just going to use our graph to answer 2 questions. The first question is, use the graph to find the value of a 5.5 carat gemstone. So to find 5.5, well, here is 5 and here is 5.5. I'm going to go up there and read off my graph, and it's going to be approximately, so it looks like it's approximately 300 and I don't know, so let's make that about $380. Now, as long as I'm showing you those lines on the graph, remember that I had to do that. As long as I'm showing the lines on the graph, I should be able to get those marks. Use the graph to find the weight of a gemstone that is worth $500. So once again, we're going to go to our graph. Here is $500. So I'm going to draw a dotted line across there, and I'm going to come down and attempt to read off what that is. So that looks like it's approximately 6 point, I don't know, 6.3. And I could use a graph, but I could also use that formula that I was given, because I've been given that V is 500, and I have this wonderful formula that said to me V equals 12.5 W squared. So I could just substitute in, and I could check that I've got an answer that is in the ballpark. So if we do this, and don't forget to take the square root, so you're going to divide 500 by 12.5 and take the square root of that, you get 6.325. So we're kind of on the right track. So using the formula would be more accurate, but we were asked to use the graph. Last question. A rectangle has a perimeter of 24 centimeters. Write an expression for the perimeter involving length and breadth, and hence write an equation for B in terms of L. Well, that looks a little complex, but it isn't really. First up, I'm just going to draw a rectangle because it's going to help me visualize what's going on. And I have length and breadth. So I know that to find the perimeter of something, I add my two lengths and I add my two breadths. So that means I've got two lengths and two breadths equals the perimeter. But I'm also told the perimeter is 24. So 24 is equal to two lengths and two breadths. And it's saying write an equation for B in terms of L. So that means I want to say B equals. So I'm going to do 24 and I'm going to take 2L away from it to get 2B. And to get B by itself, I'm going to divide both sides by 2. So I get B equals 24 minus 2L over 2. Now the other thing I can do is I can see that 2 goes into 24 and also into 2. So 2 into 24 gives me 12 minus L. And so now I have B in terms of L. Now I'm going to find an expression for the area. Now we know the area of a shape, of a rectangle I should say, is length times breadth. So we have length, but we have just found out that breadth is 12 minus L. So if I was to expand the brackets, I get 12L minus L squared, and that is the formula for the area. So now I'm being asked to complete a table of values and draw a graph. So I'm going to get you to pause the video and have a go at doing that. So you can see I've now filled in the table of values and I have drawn my parabola as best I can. Obviously yours will look a lot better than mine. And once again, there are just a couple of questions to answer. What is the maximum area and when does it occur? So the maximum area, we're looking at the area side. So we can see from here or from our table that the maximum area is 36. So 36 meters squared gives us the maximum area. Can the length be 13 or 0? Well, we can't have 0 because you can't have negative length. You'll just have a straight line. And the length can't be 13 because there is no way we can then make that give us our perimeter of 24. So there is no way that this could happen. So no. Find the value of A when L equals 3.5. So we can find when the value of L, so 3.5 is here. So from my graph, when we have 3.5, it looks like I get approximately 29. And the other way I could check is I could use the formula that I created, which I created was A equals 12L minus L squared. So I could try with L being 3.5 and see what my calculator gives me. And when I do that, I get 29.75. So there are two ways of coming up with the answer. Probably the better way, the more accurate way would be to use a formula because our graphs aren't going to be perfect. I hope this all makes sense. If you have any questions, ask me in class.